All right, so today we'll be talking about intermolecular forces. Again, this is going to be very quick, not too much. Again, end of the chapter that we see here. All right, so with intermolecular forces, these are forces of attraction between molecules. So in the hydrogen chloride molecule, for example, the partial charges on the hydrogen and chlorine atoms are electrically charged regions or poles. A molecular that has two poles is called a dipolar molecule or a dipole. So again, we see a negative charge with the chlorine atom. We see positive charge with the hydrogen atom. Again, this would be a dipole, two poles. Okay. We see dipole-dipole forces. So these are strong force of attraction between polar molecules. So the electrical attraction occurs between the oppositely charged regions of polar molecules. And again, this allows for these different molecules to come together. We see this with water between oxygen and hydrogen. But again, that would be more of a hydrogen bond in some cases, especially with water. But again, with these dipole-dipole forces, again, because of the charge, this is attracting opposites together. And so dipole interactions are similar too, but they are much weaker than ionic bonds. Hydrogen bonds are attractive forces in which a hydrogen covalently bonded to a very electronegative atom. So again, nitrogen, oxygen, or fluorine is also weakly bonded to an unshared electron pair of another electronegative atom. It is the strongest of all intermolecular forces. Hydrogen bonding always involves hydrogen. Must be a polar molecule, so examples of this would be hydrogen fluoride, nitrogen trihydrogen, and dihydrogen monoxide or water. And then, is it strong? HNOF. So, again, we know that it will be strong enough. Okay, so again, we have this water molecule here. Ice and hydrogen bonding. Again, we're seeing the hydrogen bonding between the two. Again, this is causing the different shape of that. And again, depending on the temperature, they will form different structures. And again, we see with this oxygen atom here, again, the oxygen or this water molecule, this oxygen atom is negative while these hydrogen atoms are positive. Again, because of the positive, negative, they're going to be attracted to each other. All right, last one here. We have intermolecular forces. So dispersion forces, this is the weakest force of attraction between nonpolar molecules caused by momentary dipoles of constantly moving electrons. So essentially what we've seen is that when moving electrons happen to be momentarily more on the side of a molecular closest to a neighboring molecule, their electric force influences the neighboring molecule's electrons to be momentarily more on the opposite side. So if you have two neon atoms, then we see that the positive side is going to attract the negative side of that atom, and this is what we're seeing here. So again, it is neutral throughout the atom, but once you introduce that neon atom, again, the negative wants to get to the positive, and that's what we're seeing here. And again, the negative wants to stay from this negative, but the positive wants to be with the positive or negative. And that is it for the different intermolecular forces that we see.